Hello there, Miss Argos, fabulous, fantastic fourth graders. It is Thursday and time for Mrs. Rotola to come and help you with some of your reviews. We don't have too much today, so I'm not going to give you all the answers. I'll guide you a little bit, and then it's going to be up to you to finish it off. So first, we're going to start, of course, with a joke. And I know you were talking about the moon, and so I figured I'd find one out about that. It says, how are a dollar and a moon similar? A dollar and a moon. They both have 4 quarters. Haha. Love that joke. All right, let's start with number 13. It says, Aiden sorted polygons into groups. The polygons shown belong in the same group. So this one, and this one are all in the same group. Which description best represents this group? So we see polygons with perpendicular lines only. At least one pair of parallel lines. Polygons with acute and obtuse angles only. And polygons with right angles only. So these are some of the words you need to know in order to choose the correct answer. Perpendicular, if you will remember, perpendicular comes and makes a very nice square angle, which we call a right or a 90-degree angle. It can be perpendicular this way. So when they're talking about perpendicular lines only, that means that every line in this object, and this object has to be parallel, meaning you have to have one of those 90-degree angles. All right, polygons with one pair of parallel sides. And if you remember from our little 2 L's together, a parallel line can look like this, they can look like this, they can look like this. But the most important thing is they never touch. So does each one of these have one pair? This is a pair. This is a pair. So do these each have at least, they could have more, but they have to have at least one pair. Polygons with acute and obtuse angles only. Remember, acute, a nice small little angle. Acute. Obtuse, a bigger angle. So, do each one of these objects have an acute and an obtuse angle in them? If so, then that's going to be your answer. And then the last one says right angles only. Right angles are those 90-degree perfect corner angles. So does each one of these objects have a 90-degree angle? That's how we're going to look at that one. All right? Okay. Now the next one we've done before. It says which angle does not appear, and here's your key, does not appear to have a measure of 116 degrees. In other words, your brain should be telling you 3 of these will be 116 degrees. One of them will not. All right, so instead of doing this for you, I thought I'd do one of these. See if I can make this a little bigger so you can see it. I don't know if I can do that on this phone. Okay. It says which angle is closest to 70. So really all I wanted to do was show you the 2 ways that you used to figure out what is in the middle of these angles, because that's what you're going to need for these. Not all of them will start at that 0 point for you. All right, so let's start with the first one. We want to know, is that closest to 70 degrees? So the one way we can do it is we can just take jumps. So we can go, I'm going to use the one on the top, and right now we're at 90 degrees. So there's 10, 20, 30, 40, 50, 60, 70. There is 70 degrees between that. So remember, you can take your hops by 10, you can take your hops by 5. That's one way to figure out what angle is in between these two lines. All right, this one I'm not going to do because it does start at 0. Keep in mind, you are starting with 0. You do not start counting at 180 and go backwards. So we can just go right around this line and say that this is 110 degrees. Obviously, that is the one that's not 70. All right, now we're going to do this other one, the next one. And instead of doing the hops, I'm going to use the subtraction. So I'm going to go ahead and I'm going to use the top line, and it's going to say 70 right here. And I'm going to keep going around the top line, and this says 110. So I'm going to take these and I'm going to subtract. I want to find the difference. How much is in between 110 degrees and the 70 degrees? All right, 0 and 0 is 0. If I have 1, I cannot subtract 7, so I'm going to go ahead and borrow. And now that makes it 11, and that's going to be 4. Okay, so I have two ways of figuring this out. If you would like to do the jumps, sorry about that. If you would like to do the jumps, you can do them by 5s or 10s to figure out how many degrees are in between the two rays of the angle. If it starts right at 0, you're going to start at 0 and just go along either the top or bottom line, wherever it's 0, and you would end up somewhere. Or if you like the subtraction way, you can either use the top two numbers or the bottom two numbers. Let's say if I use the bottom two numbers, this bottom is 110 and this bottom is 70. Well, my goodness, it just looks like the top. Okay, so it really doesn't matter which one you use. All right, so you're going to use this logic that I showed you these ways, and you're going to find the one that is not 116 degrees. Okay, good luck with that. I don't think it should be that bad for you. Okay, and the last two that we have to do for Thursday is you're shown this figure below. Which of the line segments appear to be what? Perpendicular. Do you remember from Tuesday's lesson? Perpendicular means you are creating a beautiful, straight, right angle, a 90-degree angle, whatever you want to call it. So you're going to go ahead and you can get, if you have different colors, let's just do the first one together. Line segments QK. So I'm going to kind of color this one in green. That's QK. And I'll get my pink over here, and let's find LK. So LK is going to be right here. Here's where they meet. I can even turn it. Does that look like that beautiful right angle? No, it does not. My beautiful angle would be more straight up. So I'm going to say, nope, that is not perpendicular because it's not making me a right angle. So you are responsible for doing the same thing for B, C, and D. Please go ahead and move your paper around because that's going to help you see, is that truly a nice corner straight angle? All right, and the last one, you guys love to do these, and these are quite simple, but there is one word that could trick you. It says, Ariel outlined these figures. You see figure N, figure P, figure Q, and figure R. Which of these figures appear to have a vertical line of symmetry? A means 1. A. Give me a pencil. That means I want 1 pencil. So which ones have 1 vertical line? Uh-oh. Vertical. What does vertical mean? Vertical. If you stand vertical, you are standing straight up and down. Okay? So keep that in mind. Which one of these, or how many figures, have a line of symmetry that would be vertical, vertical, vertical. All right, and with that, you should be able to figure that one out. So have a great rest of the day on Thursday. Do your work, be safe, and I sure hope I will be seeing you soon.